Can we go ahead? Oh, actually, you were right. So basically, in the rate limits, we have country-based, we have cloud IPs, and we have server level, right? In the country-based rate limits, we do, so basically we learn about the bot attacks that have happened in the past and which region it kind of originated from, right? Let's say we figured out that this region or this country was the most prone, and we know Flipkart.com shoppers, where they often shop from, right? Beyond India or beyond, let's say, some few people in US, we know that there could be no real customers residing in those areas where we kind of say that, hey, this is a genuine shopper, right? So you kind of put these country-based limits, right? So you kind of say that if IP exists from this and this country, we kind of say, okay, let's rate limit those. So you can have multiple rate limits in your system. It's not like it is one for all, right? So let's say if you say, I'm going to only approve 5 requests from a country outside of India, then that rate limit for outside of India becomes 5, right? But inside India, you can have a different rate limit altogether, right? Then you have known cloud IPs. Most of these DDoS attacks, right, they originate from GCP, AWS, right? So cloud-based attacks also happen. So you kind of find a way to figure out what could be the right rate limit here. Now, this is not an easy job because genuine customer or genuine people could also reside on these clouds, right? It's not necessarily that if it is coming from a GCP or an AWS, it's a bot attack. So how do you do that? We have a lot of solutions in place which kind of give you a number, right? So you put it in your system. When a request comes, based on the machine learning and the things that this system has seen in the past, it comes up with a bot score, right? So a bot score can range from 0 to 100. A score of 0 means this is a genuine user. A score of 100 means it's a 100% bot, right? So we kind of figure out what is that X number that we want, where we qualify bot, and we say no, right? So these systems which detect the bot score and give us the score back, we kind of then figure out what is that X percentage of users we want to go through our systems and what is that X percentage of users we want to say bye. Right? So this is the known cloud-based IPs. The server level, the one that I was talking about in the each pods that you've seen, is a rate limit that is beyond anything. It is irrespective of your, I wouldn't qualify it as bot traffic or non-bot traffic. I would just say traffic. So anything beyond that X traffic, that pod or that server is not able to handle, it will say, hey, we've reached our maximum limit. Beyond this, I cannot take it. Right? So these are the things that we keep in our system to kind of preserve them from 2 things. 1, not letting you see a lot of 4 to 9s, right? And 2, preventing the bot attacks. Can we move on, please? The next thing that we are going to talk about is the connection limit. If you've seen that diagram, right? Flipkart.com, MWeb, desktop. Similarly, you have 2 other channels, Android, iOS, right? Now, let's say traffic comes at www.flipkart.com. Based on the user agent, I segregate it goes here, it goes there. Imagine a situation where one application is sending these requests to the upstream, right? Is continuing sending these requests to the upstream. Let's say, okay, let me give you an example. Let's say there's a bot attack, okay? And the bot is targeting desktop, right? Now the bot has started targeting desktop, which means all the requests go over to that side, if you remember that diagram, right? All of these requests go to the other side, and which means the desktop servers are operating at their maximum capacity, right? Now imagine the fan out, into 4, into 4, into 4, they're choking our upstream systems, right? Upstream systems keep on getting these into 4 requests. Now imagine this resource here, msite. This poor guy is making genuine requests. You're logging genuinely from msite, right? But because our upstream systems are so choked, you're getting a latent response. Your msite is not loading. It takes 9 seconds, 10 seconds, and then you suddenly see a broken page, right? Because we hit our timeouts. So one bot attack which ideally should have just brought one system down, suddenly has brought all systems down, right? That is the downfall of such an infrastructure, right? And we kind of wanted to prevent that, right? How do you prevent that? You set up connection limits. You say each resource is only going to take X number of connections. Beyond this, if desktop is taking X plus Y, I'm not going to honor that, right? Because if I start honoring that, rest of my systems will go down. So we set up connection limits at our resource levels, where we say that this is the connection limit beyond which I'm not going to serve via this channel, right? This is what is written in the slide as well. If X application is getting a huge amount of traffic, it can result in a higher latencies, right? And these connections will start piling up. The previous connections are not complete, the new connections start piling up. And there's a resource hogging that is happening, right? Which is basically what the DDoS or the attackers do. They want to consume all the resources and leave none for our genuine customers, right? This is how you prevent that. You put a connection limit at your system. Next slide, please. So there's a way that you can theoretically configure these connection limits, but as I mentioned, it takes a lot of historic data to come up with the right connection limit. Just saying that connection limit is QPS into latency is not the right way to put things, right? A connection limit, just like rate limit, has to take the historic data into account. What were the sort of bot attacks? So in preparation for these sale days, we have to go back to the historic data, the number of bot attacks that we've faced, how many times our systems failed, how many times our systems survived, right? The failure, right? At which threshold did we fail? The survival, at which threshold were we able to accommodate that? All of these govern these variables, the rate limit, the connection limit, and the timeouts, right? So there's no easy way of doing that. And that is what I wanted to call out. Like, behind the scenes, there's so much going on in these seal days that users really don't get to see. Sure, let's move on to the next slide. The last bit of it, the last bit of configuration, is the timeouts. I think many of you are aware or familiar with how timeouts work, right? Anybody who's not aware? All right. So timeouts are basically, to loosely put it, you put X seconds timeout, right? If you breach that threshold, if you cross that to X plus 1 second, you will see an error page, right? Because the systems, let's say my upstream systems had been latent. I expected the response to come in 7 seconds. They gave me the response in 9 seconds. I cannot keep my user waiting forever, right? Plus, I'm kind of choking the connections for other users who are probably using it. So I say, hey, at this cutover, I'll return an error page here. So timeouts are as important as your other configurations in the system. But they're also double-edged swords. Let's say you put wrong timeouts in the system. I put very aggressive timeouts, 1 second. Okay, beyond which I will not accommodate any API request. What will happen? Beyond 1 second, your customers will start seeing error page. What will they shop? Right? So you have to be very, very kind of judicial into knowing what is the right timeout in your systems. That is why I'm calling it a double-edged sword. And that is why I'm kind of complimenting my team to come up with the right thresholds of each of these things, because it's not easy. One wrong move, the entire Flipkart page goes down, whether it's because of timeouts, whether it's because of wrong rate limits or wrong connection limits, right? So they are double-edged sword, and you have to, again, go back to your historic data to see what kind of timeouts were there, what kind of timeouts do work for you in the longer run. So how do we calculate these timeouts? There are two kinds of timeouts: server timeouts and the API timeout, right? When I say server timeout, I'm talking about node servers. We work on node servers. And there's an API timeout. As I spoke about, we have, like, let's say a 4x fan out from our node server. So our API timeout will be very different from server timeout. You see one request, one response. We see one request, send 4 other requests, get 4 other responses, kind of collect all that data and send you one response. That is why these two timeouts are entirely different. API timeout, you look at the graphs of your API providers you see what is their maximum latency. Everybody aware of the term P50, P75, P99? Okay, I'll just explain a little bit in detail. So P50, P75, P99 is percentile, okay? Basically, if you put X customers in rows, right? 100 customers in rows, they'll occupy 100 rows, right? The 99 percentile is the 99th row. What is the 99th? So you kind of sort it into ascending order, right? So let's say our 50 customers who are working on good network were getting the response in 3 seconds. But the last bit of customers who were, let's say, very, very slow on a slow 3G network were getting the response in 10 seconds, right? So that is called as percentile latencies. We operate on those sort of terminologies. So we saw the P99 latencies for our upstream service, which is the lowest kind of, what is the largest time that this API is taking to complete. You can assume that, right? And we kind of put those timeouts, +1 or +2 or +X. We said after this, we will not entertain this response. Similarly, from your server timeout, you can do 4X because you have 4 fan out. So you can do, okay, this API is taking maximum 1 second, this is taking 2 seconds, this is taking 4 seconds. You can add all of those, put that as your server timeout, right? So this is how you can put various timeouts in your system, beyond which your users will see an error page. Can we please move on? Now we have put so much into our system, right? And as I said, unless you have observability around it, what is the point of it all? So let's go on, please. What is observability? As I mentioned, that there are few things that you need to do in your system where you are able to figure out that what is going wrong so that you can fix it, right? One of the most important things is the debug environment. Unless you have logging enabled, you won't be able to figure out what is going wrong, right? And that is why logging is so important in your systems. Because log gives you a detail that the end customer report will not give you. The request ID, the timestamp, where is the request hopping from, where did it die, right? All of these logging, you will be able to find out if you have set up a right debug environment. The second point is handling the error cases. I think Yash is asking me to move. I will. So handling error cases, right? So make sure that even if your systems go down, your customers are not seeing a very random HTML page with a random status code, right? Because that is the worst that your customer can see. At least have a proper error page with a retry mechanism. On web, of course, we do not need a retry mechanism because you have the browser refresh. But let's say we are doing it on apps, right? We have to keep a retry button. We have to ask them that, hey, click it after 10 seconds. Maybe maybe our systems are latent right now, or maybe we are having a surge. Maybe after 10 seconds, it's going to work, right? So have a proper experience for your users to handle these error cases. And last, have some degradation levers. None of it works. Imagine none of these connection limits, rate limits, timeout. Nothing of this works, right? What should we do, right? So we have SSR, right? Server-side rendering. I hope all of you are aware of it, right? What is the advantage of SSR? Of course, it's faster experience, SEO, this and that. But in the worst case scenario, imagine you're going through a sale and every server is down. What do? You have to have a degradation lever to switch it to client-side rendering so that the browser request is in the browser itself. There's no surge, right? So you should have these mechanisms as a failover strategy always in your system. Can we move on, Yash? And the result, this was the most glitch-free sale period ever. And we handled not just 10x, we handled 20x BAU traffic, this BBD, right? All because we tried to find the right strategy, because we fixed our code and we fixed our past mistakes. I think that is it. I don't think I have another slide. Oh, I do? Okay. So thank you again for coming and listening so intently.
Hello.
A lot of these terminologies you might not be aware of, as I understand,
Hello.
because not all of you might be working in the same area of expertise. But please feel free to call me or reach out to me on Twitter, and I'll be happily able to answer your questions. And if I faltered anywhere in my presentation, or you may have, had a feeling of being a sleepyhead, then I'm so sorry. I hope all of you enjoyed the session. Thank you.